Okay, so now we're connected. Let's use Thonny. Thonny is a very useful integrated environment for either regular Python or MicroPython. So in this case, we're using it for MicroPython. So let's see, over here we can select the type of MicroPython, and also we can select the serial port. So let's go ahead and drop down Tools menu. Under Options, we'll go to Interpreter and select the Raspberry Pi Pico. And the port is number 12. So okay, so let's get started. Okay, here we have it. It's running already. So how do I get the SDI 12 sensor to respond? Okay, so first we need to start a serial port. So here's the syntax from machine. Machine is a module that includes a lot of different features. Serial port or UART, GPIO pins, SDI or I2C, a lot of different features on the machine. So we'll import UART and the pin. Okay, oops. Okay, so there we go. And now we can establish a UART 0. The Raspberry Pi Pico has at least 2 UART ports that I know of. And UART 0 is equal to UART. So we're going to instantiate the UART 0, a serial port 0. With a baud rate of 9600. This is the SDI 12 adapters rate. Also the same for the mini module. And the TX, this is the pin on the Raspberry Pi Pico. And according to its reference, the GPIO pin 0 is the TX. And GPIO 1 is the RX. There are also other pins that can act as these TX and RX for this particular UART port, but I'm not using it. I'm just using the default. So here it is. Now I have the serial port. The nice thing about MicroPython or Python in general is it is interpreting language. So as you type, you can start asking for questions like things, whether they're let's see, what is UART 0? Okay, how the options have been listed. So we can look at it. Baud rate, bits, and the parity. Seems like everything is in order. Okay, so now we can start reading. So UART 0 is that instance. See, I have that, and we can read, and then we need to specify how many bytes to read. But what if I don't know how many bytes? So I can use this UART0.any. So the any actually returns the number of available bytes to be read. So we'll read all the available bytes. Are there anything? I don't know. Maybe there's something. Well, there's nothing because I just booted the system. There's nothing from the mini module. So let's do a write 0.write. So what I want to do first always is to test the mini module first, see if it responds with its own address when it's polled. So we start with the B. The B is a byte array. So just B single quote and Z capital I exclamation sign, and close the quote and the parentheses. So this is asking the module, the SDI 12 mini module. Okay, so the 3 just means it sent 3 bytes, one for each character. And now if we do this, this is going to catch the response from the SDI 12 module. There we go. So it's running just a regular SDI 12 firmware, and that's the response. See, the response is always \r\n as per the SDI 12 standard, and the request always ends with this exclamation sign. Okay, so now we know the module works. We can start polling to see what's on the bus. So I only have one sensor. If you remember that was an old decagon sensor, a soil moisture and temperature sensor. So I'll use the question mark. The question mark will only work if there's a single sensor on the bus. Otherwise there'll be some conflicts. again, I'll do this, read any bytes. That means all the bytes have been returned, and there's only one byte, the address of that decagon sensor, and then followed by \r\n again. So as any response will have these 2 bytes. Okay, so now I can ask, what kind of sensor are you at address 1? So 1, capital I, exclamation sign. So I'll send this out. Again, 3 bytes were sent, and we'll read and see what's the response. Okay, there we go. So it's a decagon 5TM, and \r\n again. Okay, so now we know the sensor is responding. We can start polling for data. So polling for data, 1M exclamation sign. That's the measurement, right? So we'll tell it to measure. So what the sensor will do is it'll tell us how many bytes, how many values it will return in how many seconds. And then it almost always returns these values before those seconds were up. So it will actually also do a service request, which is its own address. So let's see what it returns. Okay, so that's a little bit more. So we have the 1, which is the address, 001. So it requires 1 second for measurement. And here's a 2. This 2 means it returns 2 values, which is, if I remember right, the temperature and a value that you can calculate into soil moisture. Okay, so \r\n, that is the response, direct response to the measurement command, which tells the host it has 1 second, it needs the 1 second, it will respond with 2 values. And then before that 1 second was up, it sent out this 1 here, which tells the host, I'm actually done beforehand, before the 1 second expires. So then \r\n again. So basically these are 2 separate responses. One is telling the host, okay, I have 1 second and 2 variables or values. And the next one is, I'm done. So, okay. And now we can read the data, D0. And that's 4 bytes sent. So we'll read it back. There we go. So, oh, I see, dielectric constant. So 1.0 would be air, and I have the sensor on the table, not in soil, so it's close enough to the air. And this one is the address. And plus 1.01, then plus 25.5, and that's my room temperature. And then \r\n. So this is how to use the Raspberry Pi Pico and running MicroPython firmware. It's very, I would say, it's very clear what we're doing. So if you back up using the up key, so this is the first command. We're going to import the UART and the pin modules. And then the next one here is establishing the UART, initiating the UART, 0, the baud rate, the pins that I was connecting between the Pico and the mini SDI 12 module. And then the next thing to do is to pull the module itself, and using write, make sure you have the B here indicating this is a byte array, not a regular say Unicode string, right? We're only sending byte arrays. And then we can, let's see, I don't think we did that. Where was that? Okay, here, this one was next. So you read back the entire response, maybe after a second of waiting, because I was talking, there was enough wait, right? So that will read anything that returns. And then what else I did was I was polling, right? This will respond with a 1, and this would respond with the sensor's info, and this would be the measurement command. Make sure you read the response back, and then this is getting the data out. Okay, so with each of these, you can pair with a read to read back the results. All right, thank you.